Welcome back. We're now on part 6 of Intro to Functions, and we're moving into the domain of specific functions. So I think this is where students usually start getting a little bit lost. So I'm going to encourage you to just try and listen through this while I read. So the domain of specific functions is the heading. Domain of a function is the set of all inputs for the function. Think about the square root in your calculator. This is a good example of a function. You put an input under the square root and the calculator assigns a number to it. Try putting a 4, a 7, a 2.17, etc. into that function. If you put 0 in, you'll get a 0. What about 2/3? See what happens if you put a -9 in. You'll find that there's a problem when you put negative numbers inside a square root. This is because you're trying to find a number that would give you an output once an exponent has been undone. So it's dividing an exponent out. Because of this, sometimes the domain is explicit and it's included next to the function. For example, when you have f of x equals 3x, it will say something like x is greater than 5, which means you're only supposed to put domain values or inputs into this function where the inputs are greater than 5. If the function is given algebraically using symbols rather than graphs or a table, and the domain is not stated, the set of all real numbers in which the function is defined as a real number will be the domain. So if you look at a table of values in your calculator, it will actually tell you where the function is not defined, and it will say undefined. Remember these rules. 0 in the denominator is undefined, and taking the square root or any even root of a negative number is undefined. Let's look at our first example. In example 1, actually it's example 5, but it's example 1 in this video, we have t of x equals 5x cubed. The domain of this function, first let's graph it. The domain of this function looks like a very skinny cubic function, where it's actually been scaled vertically by 5 because the 5 in front. Notice that any value I put into this function as a domain value will give me an output. I could put a -3 in there, and it would be 5 times -3 cubed. And that's completely doable. My calculator will not be upset at me. I have not done anything mathematically wrong in that statement. And I can also substitute positive numbers in. There are no restrictions on the domain. So I could say, using interval notation, that my domain is from -infinity to +infinity. You could also say all real numbers So sometimes you'll see this domain and then a colon and then the interval on which it is true. Or you could say all real numbers. Or there's this shorthand that people will use. It's a double-lined R, and it means all real numbers. So these two mean the same thing, all real numbers and the symbol R. This would be the domain of this function. Because number 1, there are no denominators, and 2, there are no square roots, or even roots for that matter. In example B, we have f of x equals 2x squared plus x. on the interval from -1 to 4. There are two different ways you could think about this. You could look at it and you could say, well, any number that I put in between -1 and 4 as an input or a domain value will give me a real output or range value. And so there are no restrictions on my domain other than what's listed. Now remember, it says state the domain of each function in interval notation. So looking at this statement here where x is between -1 and 4, we can write this in interval notation. We know that our interval includes -1 and it does not include 4, and it's anything in between here. So I can write this as open bracket -1 to 4 close parenthesis. That's the interval for my domain. If this interval had not been explicitly stated here, my domain values would have been all real numbers. Let's take a look at C. We have h of x equals 3x minus 5 over x plus 1 plus x. Now we check this for fractions and for radicals, or even roots. And we don't have any roots, even roots, but we do have fractions. And remember, just like when we were looking at rational expressions with inequalities, we have to restrict the domain so that we do not have vertical asymptotes in the denominator. We don't include those values. So x plus 1 cannot equal 0 because there will be a vertical asymptote at 0. So I'll go ahead and do a number line here. We have -infinity on the left, +infinity on the right. When I solve for x here, that would mean I would subtract 1 from both sides of the equation, and x will equal -1. That is where my vertical asymptote is. So at -1, there is a hole in my number line. Otherwise, any values I substitute in as my domain values will give me range values out, and they will be defined. So my interval is from -infinity to -1. I do not include -1. There's a hole at -1. And then infinitely close to -1, but not including 1, to infinity. Remember, you always list your intervals from smallest to largest. And if it helps you to draw a number line so that you can see where the holes on your graph would be for those vertical asymptotes, you should go ahead and draw those until you get more comfortable with defining the domain of the function. I hope this helps with your homework and also with understanding how to use inputs or domain values to get an interval on which the function exists.